Hello everyone. Last module we discussed about assembly drawing of a transformer, where we covered both a single phase and three phase core and then shell type transformer. So in that we discussed about a front view and then a top view of a transformers. So now in this module what we'll be discussing about assembly drawing of DC machine. It means it consists of both DC motor and as well as DC generator, whereas the constructional features of both DC motor and then DC generator is similar. That's why commonly we are calling it as DC machine. So before actually developing a drawing of a DC machine, so we should know the constructional features of DC machine. So session objective is to discuss about a construction features of DC machine and how the main components or main parts of a DC machine looks from the top, looks from the front view and as well as the top view. That is what we are going to discuss. Okay, I hope you remember in your electric motors, if the question will be asked like this, with a neat circuit diagram, explain the construction features of DC machine. So you will be writing this diagram, right? So this is nothing but an end view. This is nothing but a front view of a DC machine. As I already said, I am using DC machine. It means it may be a DC motor or it may be a DC generator. As I already said, both are having a similar construction features. Right? Coming to this is what the end view of a DC machine. This is what your end view of a DC machine. So coming to the main parts of DC machine. So before going with that, the main parts of a DC machine, so let me recall the working principle of a DC motor. So the working principle of a DC motor is what, if you placed a current carrying conductor in a magnetic field, it experiences a torque, that is nothing but a twisting force, right? A rotating force. So it means we should have a magnetic field here and we should have a conductor which is carrying a current. This is what, right? These are the basic requirement for the DC motor, right? So for that here, based on that the working principle, we are having some major components in DC machine. The one of the major component is what? Yoke. So yoke, it's an outermost cover of an electrical machine. It protects the machine and also it provides a path for the magnetic flux. So where that magnetic flux comes from? The magnetic flux will be established, will be produced by the field poles and then interpoles along with the windings. This is another major part. So as I already said, I should have a magnetic field in order to produce a torque. So where that magnetic field comes from? From the field poles along with the windings, field winding. Okay, this is what the field poles. And then I should have a current carrying conductor to place in that magnetic field. So here we will be having an armature winding. That is what armature and armature winding, where the armature winding acts as a conductor which carries a current. Okay, so this is what armature and armature winding. And lastly we will be having a commutator. So it will collect the current from all the armature windings in case of a generator, and then the brushes to collect from the commutator and then the end place. So here you can see the assembly of an DC machine. So the field poles or main poles, this is the field winding which we can wound on these field poles, and the yoke which is an outermost part of a DC machine, and you can fix these poles by using this field pole screw. And along with that you can see here, this is the armature, this is the armature and the shaft. The armature is placed over the shaft, and here we have a commutator next to the armature so that it will collect all the induced current of an armature. It will be collected by the commutator, and these are the brush holders which are placed on this commutator. This is nothing but your complete assembly drawing of a DC machine. Now coming to the cut sectional view of DC machine, you can see this is what a cut section view of a DC machine, how the DC machine looks like. So here you can able to see this is the central limb. Central one is nothing but your shaft, and over that here we'll be having this is what the, as I already said, the field pole screw, and this is the field magnetic pole, and these are the field windings which are wound on this pole, and here we have a armature, and this is the commutator. So from here to here it will be this is the riser portion of the commutator, and this is the commutator, and you can see this is the brushes where we placed on the commutators. So this is what a cut sectional view of DC machine. So before going with that, let us see some images which gives more details about constructional features of DC machines, how the armature looks, how the commutator looks exactly. Okay, now we have an armature here. You can see this is what an armature core, and these are the slots where we can place the armature windings. These are the slots. In slots also we will be having different types: open slot, closed slot, and then semi-closed slots, like that. Depending upon the size of the machine, the slots design will be selected. And this is what a slot, and then this is the teeth, and these holes are nothing but ventilating holes, or we can also call it as cooling duct. And this is the hole for a shaft, and this is what an Allen key. This is nothing but your armature core. And armature core, as we already know, it should be laminated. This is how the multiple armature cores will be laminated together to reduce eddy current losses. Okay, so what you are looking now, this armature, so this is the front view. This is how the armature looks from the front. That is nothing but your end view. And next we'll be having a commutators. Here you can see that this is the armature part, and here we have a slots where the conductor is placed inside, and you can also see that all the conductors are connected with the commutator. This is the commutator. Okay, this is what your shaft, and here also you can see the commutator here. So this is the riser part, and this is the commutator. So in between the commutator segments we'll be having an insulation between this, and this is what a single commutator segment. This is what a single individual commutator segments. And coming to the brushes, as I already said, it should be made up of carbon. Here you can see this is what the brushes and how it will be placed. It will be placed on the commutators like this. This is how it will be placed. And now let us go with a different views of main parts, right? Basically in assembly drawing of DC machine we'll be going to develop two views. One is an end view and another one is what elevation. End view is nothing but your front view, and elevation is nothing but your top view. So here firstly I am going to consider the yoke, the outermost part of a DC machine. See, this is what your outermost part of the yoke. You can see here it is cylindrical in structure. So if you see from the front, you can able to see only this part. That is nothing but your end view. Okay, you can only able to this part from the front. It is nothing but your end view. That is nothing but your front view. Okay, and from the top you can able to see this position. This is what your elevation part. From here to here it is elevation. This is what your end view. So in order to draw an end view, what are the data you required? You should require outer diameter and then inner diameter of yoke to draw an end view of an yoke. Likewise, if you want to go for an elevation, you should have a axial length of the yoke and then depth of the yoke. These two data are required in order to draw an elevation. Clear? And coming to the field poles or main poles, this is how the pole looks like. This is nothing but your pole shoe, what we can call it as pole arc. Okay, the pole arc, and this is what your length of the pole, width of the pole, and then the height of the pole. Okay, this is what height of the pole, width, and then the length of the pole, or else we can also call it as a depth of the pole. Okay, so from the front means it is from point A. From point A you can only able to see this portion, right? So that is what here it is written. This is what nothing but an end view. That is nothing but an view A. Okay, and from view B, this is what your another view. From this point you can only able to see this part. That is what they have written here. Okay, this is the elevation part they have written here, and this is the end view they have written like this. Okay, so again, in order to draw an end view and elevation, so for an end view of a main pole or field pole, you should require width of the pole, height of the pole, and then the pole arc. This is the pole arc, width, and then the height of the pole. These are the details you should require to draw an end view. Likewise, for elevation, you supposed to have an LP, that is nothing but an axial length, and a HP is nothing but the height of the pole. These two data are required for elevation. So view A and then view B. View A gives an end view and then B will give you the elevation of a main pole. Okay, and next the interpoles. There will be a pole between the main poles, that is nothing but your interpoles here. So it will be in rectangular in structure. Here in this diagram you can see this is the interpole, and this is the interpole winding which is wound on that rectangular bar. Okay, this is the winding, and this rectangle is nothing but your interpole. And obviously from the front view, from the end view, it looks like a rectangle. This is what you can able to see. So for that you should require width and then height. For elevation you should have this elevation, axial length, and then the height of the interpole. Most of the cases the height of the main pole and then the height of the interpole almost equal. There will be a slight difference between the height of main pole and then the interpole. After developing an end view of an yoke, end view of an main pole and then interpole, here you can see this is what the end view of the yoke, the main pole, and then the interpoles. Between the main poles there will be an interpoles. This is generator and this is motor. There will be no changes in the construction of generator and motor as you see now. Now let us go for cut sectional end view and elevation of main pole. So here we have a main pole, and the windings are wound on the main pole. This is nothing but your field winding. As we already discussed, just a pole looks like this from an end view, but here along with that we will be having a field windings. So the field windings looks exactly like a rectangle on both the side. This is what inner rectangle, outer rectangle, and there will be a slight gap between the pole and then the inner rectangle. That is for insulation between the pole and then field coil. And these are the riveting holes, what we can call. These are the riveting holes where I can fix the poles to the yoke. Okay. So for this you should require two more data. Another one is height of the field winding and then the depth of the field coil. Height of the field coil and then the depth of the field coil along with the data of main poles. Okay, and coming to this is what the elevation, as I already said, this is what view B. So for this again you require height of the field windings along with the axial length of the pole and then the height of the pole. This is nothing but your cut sectional end view and elevation of only the main pole. Okay, and now we have discussed elevation, end view of yoke, main pole, and then the field windings. So here you can see this top of end view of a DC machine only with yoke, main, and then interpoles along with the windings. Here why it is called top of? Because the details I am showing only at the top of, not in the bottom of. That's why it is called a top of end view. So this is what the yoke, outer dia, inner dia, and this is the pole. This is the pole shoe or pole arc, and these are the pole windings, and likewise this is the interpole, and these are the interpole windings. So in this case, how many poles we have? We will be having 4 main poles, and then also we will be having 4 interpoles, and this is what a base or support for the whole DC machine. This is nothing but your top of end view of a DC machine without an armature, right? So now let us go for the next component, armature and commutator. We already discussed the structure of an commutator. This is what the structure of commutator. So this is the slots, and then there is what a teeth, and this is what an Allen key, as I already said. This is the end view of a commutator, and from ear to ear, this portion is an elevation of a commutator, and these pieces are called H pieces because the structure of this two is like a letter H, and this is also H. So how many H you will be having here? 1, 2, 3, 4, 5, right? So there will be a 5 H pieces, right? 5 H pieces in the commutator, and this is what your shaft. And next to that we will be having a commutator. As I already said, this is the riser, and this is the flat portion of the commutator, and this is the again shaft. Okay, this is nothing but your pole core packet, H pieces, and this is what your pole core packet. This is the end view of armature, and this is the elevation part of commutator and as well as the armature. Okay, now very important component is what a commutator. So here you can just see this is the flattening part of a commutator, and this is the riser of a commutator, and below that we will be having some insulation, that is what a mica insulation here. This is nothing made up of what a copper segments, nothing but a commutator segments. Okay, and here you can see the end rings. See, the same thing what they have written here. This is the copper segment, this is how it looks like. Here also you can just compare this with this. Okay, it is placed on mica insulation. Here also you have a mica insulation, and this is the central axis line, and this is the shaft. This is what the elevation part of a single commutator segments. Just I am detailing about top portion, not the bottom portion. Okay, and this is what the front view of the commutator. So it looks like armature core, but it is not an armature core, it is a front view of the commutator. These are the riser portion of the commutator. Clear? And there will be different types of commutators will be using for small and then large DC machine. For small DC machine, this is the of commutator design, and this is for large DC machine. Okay, so with this we discussed about some constructional features of DC machine. So in the next sessions we'll discuss few problems, few exercises to develop or to draw an assembly drawing of a main pole and then the end view of the entire DC machines in the upcoming sessions. Thank you.